Welcome children, take out your geography book. Today's topic is insolation. Introduction. The sun is the ultimate source of light and energy for the various phenomena that take place on the earth's surface and in its atmosphere. Our sun is a ball of constantly churning gases that are heated by continuous nuclear reaction. It is a star of average size and has a surface temperature of about 6000 degrees Celsius. It emits energy in the form of electromagnetic radiation. The longer waves largely absorbed in the atmosphere are called infrared rays. The shorter waves are called the ultraviolet rays, which reach the surface of the earth in the form of solar radiation. The solar energy travels in the form of rays at a speed of about 30,000 km per second. At that rate, sun's energy takes nearly 1/3 minutes to reach the earth. Solar radiation provides more than 99.9% of the energy that heats the earth. As solar radiation passes through space, none of it is lost. However, the rays spread apart as they move away from the sun. Thus, a planet away from the sun like Mars receives less radiation than the ones located near the sun like Mercury and Venus that receives more. Our earth is situated neither too near nor too far away from the sun. Hence, the ideal condition exists for all forms of life, and various climatic and weather processes depend on it. Although the earth intercepts only about 1/2 of the billionth of the sun's total energy output, the incoming of solar radiation that reaches the earth's surface is nearly equivalent to about 23 billion horsepower. Heating of the atmosphere. Our atmosphere is not directly heated from the sun above, but by the terrestrial radiation given out by the earth. There are three main processes by which the earth's atmosphere is heated: convection, conduction, and radiation. Convection, the transmission of heat from one part of a liquid or gas to another by movement of particles themselves is called convection. The heated air rises up, being lighter. At higher level, the rising air spread horizontally gets cool and sinks. As it comes down, it again spread and heated again and ascends again. Thus, the several circulation in the air are maintained due to the process of convection. Convection is an upward movement of air which has been heated by contact with Earth's surface, and this air is said to rise in a convection current. In other words, convection requires a mobile medium like air or water. Conduction. Conduction is a process in which heat is transferred directly through matter from a point of high temperature. Conduction transfers heat between adjacent molecules. Heat passes from warmer to colder substances as long as temperature difference exists. Thus, when the Earth's surface absorbs radiation and warms the air above it, conduction transfers part of heat to the lower layer of air. When the surface is cooler than the overlying layer, the heat transfer reverses and air is cool. The latter phenomena is common over land at night and during winter in the middle and high altitude. Conduction is confined to only the lower layers of the atmosphere where the air comes in contact with the Earth's surface. Radiation. It is a process by which a body emits radiation energy. It causes a loss of heat and therefore leads to cooling. During the day, the heat received from the sun by insolation exceeds the amount lost by radiation and the temperature rises till the maximum is reached. At night, the reverse is the case and the temperature falls till a minimum is reached. Differential heating of land and water. Land and water surface have quite different properties in absorption and radiation of heat. Land surface is directly and intensely heated under the sun's rays, whereas water surface gets moderately heated. On the other hand, the land surface cools off more rapidly. That is why temperature contrasts are great over the land masses, but only moderate overseas. Insolation. Incoming of solar radiation. Solar radiation that is intercepted by the earth is known as insolation. The amount of insolation reaching the outer limit of the atmosphere is called solar constant. Factors affecting distribution of temperature. Normally, the horizontal distribution of temperature is determined by latitude. The general decrease in temperature from the equator towards the pole is one of the most fundamental and best known facts of climatology. If the effects of latitude were the only controlling factors affecting net radiation, we would expect the world map to have isotherms lying parallel to each other in the same manner as latitude. But this is not so. Actually, the horizontal distribution of temperature is the function of numerous other physical factors as follows: latitude, altitude, distance from sea, ocean currents, winds, clouds and rainfall, the slope of land, vegetation and nature of the soil. Latitude. Places close to the equator have higher temperature and are warmer, hotter than places away from the equator. This is because the sun's rays reach the earth after passing through the layers of the atmosphere. In the low latitude, the sun's rays are direct and have to travel a lesser extent through the atmosphere. Hence, the heat of these rays is more intense. But in high altitude, the sun rays are slanting and have to pass through a greater extent of atmosphere. Hence, these rays lose heat, and so the areas in the high altitude are not very hot as compared to the equatorial region. This is the way the temperature zones are formed on the Earth's surface. For example, Chennai, a day is almost 12 hours long throughout the year, whereas Paris has 16 hours of daylight in summer. Still, Chennai is warmer of the two. The reason of being 12 hours of direct rays from the overhead sun has much more heating capacity than 16 hours of slanting rays of sun in Paris. It means that those places that lie within the tropics are warmer than those places that lie outside the tropics, where the sun rays are spread over a larger area. And with this, I am ending my today's class. Goodbye.